Imagine looking into a mirror that doesn't show your reflection, but instead reveals a moment from billions of years ago. That is one of the most extraordinary things the James Webb Space Telescope allows us to do. When Webb observes an extremely distant galaxy, it is not seeing that galaxy as it exists today. The light reaching its mirrors began its journey billions of years ago, long before Earth had formed and long before life appeared on our planet. Every photon is therefore carrying a piece of cosmic history. Webb was designed to investigate that history by observing some of the earliest stars and galaxies in the universe. According to the Standard Model of Cosmology, the universe began approximately 13.8 billion years ago in the event known as the Big Bang. As space expanded and cooled, particles formed and eventually combined into atoms, primarily hydrogen and helium. Then came what scientists call the cosmic dark ages. There were no stars shining through the universe yet. Gravity slowly gathered matter into increasingly dense regions. Eventually, some of those regions became dense enough for the first stars to ignite. Those stars transformed the darkness. They produced enormous amounts of energy and began creating heavier elements inside their cores. Over time, groups of stars gathered into the first galaxies. For decades, scientists expected this process to happen gradually. The earliest galaxies were expected to be small, irregular, and relatively undeveloped. Large, organized structures were thought to require much more time to emerge. Then Webb began observing the distant universe. Instead of finding only primitive systems, astronomers discovered galaxies that appeared surprisingly bright and structured despite existing extremely early in cosmic history. Some distant galaxies showed evidence of organized shapes and intense star formation. These observations do not automatically mean that our understanding of cosmology is wrong. Instead, they raise a more interesting question. How quickly could galaxies actually form and evolve in the young universe? Astronomers must consider many possibilities. Perhaps early galaxies formed stars much more efficiently than previous models predicted. Perhaps certain environments allowed galaxies to accumulate material unusually quickly. Or perhaps our models of the earliest stages of galaxy formation still need refinement. The light from these galaxies provides another important clue. By studying their spectra, scientists can investigate the chemical elements present within them. The early universe began with mostly hydrogen and helium. Heavier elements such as carbon and oxygen were produced later through stellar processes. Stars created these elements deep inside their cores and eventually returned some of that material to surrounding space. So when astronomers detect significant amounts of heavier elements in extremely distant galaxies, they are learning something about how quickly stars must have formed and evolved before those observations were made. This suggests that the young universe may have been much more active than previously imagined. Stars could have formed rapidly, lived intense lives, and enriched their surroundings in surprisingly short periods of cosmic time. But another mystery makes the story even more fascinating. Webb has also observed evidence of massive black holes existing surprisingly early in cosmic history. These objects can reach millions or even billions of times the mass of our Sun. The challenge is understanding how they became so massive so quickly. If black holes started as relatively small objects and grew gradually, there may not have been enough time for them to reach such enormous sizes. Scientists are therefore exploring alternative explanations. Some theories suggest that unusually massive black hole seeds could have formed directly from dense regions of primordial matter. Other possibilities involve rapid accretion or environmental conditions that allowed black holes to grow much faster than expected. None of these ideas provides a final answer yet. And that is exactly why Webb's observations matter. The telescope is not simply giving scientists beautiful pictures of the ancient universe. It is exposing questions that previous generations could not even investigate. And the deeper Webb looks, the more surprising the early universe becomes. The mysteries revealed by Webb extend beyond early galaxies and massive black holes. One of the biggest questions concerns how organized structures appeared so quickly. The young universe should have been turbulent and relatively simple compared with the mature cosmos we see today. Yet some early galaxies show signs of surprisingly complex development. Their shapes, brightness, and internal structures provide evidence that galaxy evolution may sometimes proceed much faster than traditional models suggested. One possible factor is dark matter. Dark matter cannot be directly observed with ordinary light, but its gravitational influence appears to play a major role in shaping the universe. It acts as an invisible framework around which ordinary matter can gather. If dark matter influenced the growth of early structures more strongly or differently than current models assume, it could help explain how some galaxies developed so rapidly. But this remains an area of active investigation. There is another fascinating clue hidden within the chemistry of distant space. Webb's infrared instruments can detect signatures from molecules and dust located inside distant astronomical environments. Some observations have revealed complex carbon-containing compounds in regions of space separated from us by billions of light years. These molecules are not evidence of extraterrestrial life. But they are important because they demonstrate that chemically complex material existed remarkably early in cosmic history. The ingredients needed for later planetary systems were being created and distributed long before Earth existed. This reveals something fundamental about the universe. Cosmic chemistry did not suddenly begin when planets appeared. It developed gradually through generations of stars. Stars formed from earlier material, produced heavier elements, and eventually returned those elements to space. Later generations of stars and planets formed from that enriched material. Our own solar system is part of this enormous cycle. Many of the elements that make up Earth and living organisms have histories extending back to ancient stars. So when Webb studies distant galaxies, it is not simply looking at something unrelated to us. It is examining earlier chapters of the same cosmic story that eventually produced our planet. And perhaps that is the most profound lesson from the telescope. The deeper Webb looks into space, the further back in time humanity can see. Every distant galaxy is effectively a historical record. Its light carries information from a period when the universe was dramatically younger. Some photons captured today began traveling before Earth existed. They crossed unimaginable distances through an expanding universe and eventually reached a telescope built by a species that had only recently learned how to leave its own planet. But Webb's discoveries also remind us that observation and interpretation are different things. An unusual galaxy does not automatically overturn cosmology. A massive early black hole does not prove that existing physics has failed. A complex molecule does not prove that life exists elsewhere. Each discovery must be tested against additional observations and competing explanations. That is how scientific knowledge grows. Unexpected results are not the end of science. They are invitations to investigate further. Future observations may explain many of the mysteries Webb has uncovered. New measurements may reveal that some apparently unusual objects are more common than expected. Other discoveries may require scientists to modify existing models. And some questions may remain unanswered for decades. But one thing is already clear. James Webb has changed humanity's view of the early universe. It has shown us that the cosmos was not simply an empty darkness waiting for complexity to appear. The young universe was active. Stars formed. Galaxies assembled. Black holes grew. Elements were created. And structures emerged across enormous distances. The universe has always been more dynamic than the human imagination could fully capture. And every ancient photon collected by Webb gives us another opportunity to understand that story. We built a telescope to look farther than ever before. What we discovered was not the end of the cosmic mystery.